Today, I will be talking about how the immune system works and the changes to your immune system as you age. To begin, we're going to go over what the immune system does. The immune system is our body's defense system against infections and disease. It regulates our wound healing, and it separates the inner self from organisms on the outside that could be trying to compete for space or resources. This is a list of all of the types of immune system cells. We have our T lymphocytes, which originate in the thymus gland and are responsible for cell-mediated immunity, which is an immune response that does not involve antibodies. Then we have our B lymphocytes, which secrete antibodies and are found in the thymus and in the bone marrow. Then we have our monocytes/polymorphonuclear neutrophil leukocytes, which are responsible for nonspecific immunity, which is a general defense against all antigens. It uses natural killer cells and phagocytes to dispose of the antigens or foreign materials in the body. Natural killers are also used to prevent tumor growth and to fight viral infections and parasites. And lastly, immunoglobulins are specialized antibodies. Some examples are IgM, which is a first responder immunoglobulin, IgE, which helps with allergies and asthma, and IgG, which helps fight hepatitis. How does the immune system work? The immune system is activated when a foreign item or antigen enters the body. It recognizes this antigen, and the antigen will be attached to the immune system cells. Then the specific type of immune system cell will dispose of this antigen. However, the immune system can store the information about this specific antigen for the future in order to get rid of it faster next time. This is a more in-depth picture of how the B cells and T cells contribute to destroying the antigen. First, the antigen will match a receptor on the B cell, and it will be activated by a helper T cell. This causes the B cell to divide into plasma and memory cells. Plasma cells produce antibodies to attach to the antigen, which triggers an eater cell that will dispose of it. The memory cell remembers that antigen, so if it attaches again, the B cell can destroy it much quicker. Aging and its effects on the immune system is very hard to study since there are many factors that affect the immune system. It is hard to determine if the changes are caused by our body getting older or if they are caused by lifestyle or environmental factors like diet, stress, exercise, and disease. So it is hard to determine what factor is causing the changes in the immune system. Also, since aging is a relatively new study, researchers are only beginning to understand how aging can affect the immune system and how that will affect the body and its other systems. Many things happen to the immune system as we age. There is a decrease in B and T cell functioning. The thymus begins to decline and will not produce as many naive or new B and T cells. B cells can also come from the bone marrow, but since that faces decline as we age as well, we cannot gain any new B cells from there either. There is also an impaired response to vaccines, so the severity of viral infections like influenza, RSV, shingles, and pneumococcal disease are much higher than in younger adults. Vaccines fail to induce long-term protection against these diseases, so older adults have a higher chance of contracting them and can also suffer more long-term complications after contracting the disease. Older adults have a higher susceptibility to infections, cancer, and diseases, one example being HIV and AIDS. Contracting this disease in late life results in a significantly shorter lifespan and higher mortality rates. It can also result in other diseases such as chronic inflammation. As we age, the immune system also takes longer to build up defenses to specific diseases. There is an increased risk of autoimmunity, which will be discussed on the next slide, and lymph nodes are restructured as we age, which can alter the development of the immune responses. Autoimmunity is a result of an imbalance between B and T cells. It is when the immune system begins attacking its own cells and can result in several disorders like rheumatoid arthritis, fibromyalgia, peripheral neuropathy, Crohn's disease, leukemia, and multiple sclerosis, to name a few. The coronavirus in China is a present-day example of the dangers of a weak immune system. Most victims have been between the ages of 65 and 80. Since it is a novel virus, older adults have a harder time defending it because they have no previous experience with it and they have a decreased number of immune cells already. Due to their weakened immune systems, older adults have a much higher chance of contracting the disease, and without a vaccine, they are at a much higher risk of dying.